Welcome to the Artificial Intelligence Fundamentals and Machine Learning class. Today we are going to discuss an interesting topic, data pre-processing. It is the major topic has to be discussed before the start of creating a model. After the collecting the data set, we have to pre-process our data and then make our data set ready to give as an input to our model. The data, excuse me, data pre-processing steps includes various techniques like data cleaning, data integration, data reduction, dimension, data transformation, and then data discretization. Here, data cleaning. Data cleaning refers to cleaning the data in forms of filling the missing values, smoothing noisy data, identifier or remove outliers, and resolve inconsistencies. Is the data integration. Integration of the data from multiple databases on data cubes or files. And the next step takes to the data reduction. Data reduction in terms of dimensionality reduction, numerosity reduction, and data compression. And final pre-processing technique is data transformation and then data discretization. It is not a mandatory to follow the steps like data cleaning, integration, followed by reduction, and followed by transformation. The first step, major step, has to be data cleaning, and the remaining three steps can be interchangeable. Now, first we will see the data cleaning in detail. Data cleaning. The data in the real world is completely dirty. That is a lot of potentially incorrect data, or a human error, or a computer error, or some kind of a transmission error. Similarly, that is, for example, if it is an incomplete data, that is, there was an attribute called occupation, but there was a missing attribute value for that occupation. And then salary, noise containing noise errors or outliers. For example, salary, it is a numerical value but it is mentioned in the negative value. These kind of data has to be removed. And the inconsistent data, for example, the birth of the data, he is the 0372010 but his age is 42. It is irrelevant, inconsistent. So this type of discrepancy between the data has to be identified and then removed. And finally is the intentional, that is discussed as a missing data. For example, Jan 1 is everyone's birthday. No, it is an celebrated as a new year. So this kind of removal process of data is said to be data cleaning. Next comes data integration. Integrating meaning for English meaning, meaning for the integration word is combining the data from the multiple sources into a coherent source. Here in terms of schema integration, schema integration. That is, for example, if a customer ID is mentioned as a customer ID in one database and another table it is mentioned as customer number, while we are integrating those data, so it should be both should be considered to be a primary key. So, and then we have to integrate that metadata from the different sources. And next one is, while integrating, we may face some few problems like entity identification problem. For example, in few databases, the same person has been referred as a Bill Clinton, but in some other database, it is referred as William Clinton. But both the personalities may be same. So we have to clarify those data also. Next, detecting and resolving data value conflicts. For the same real world entity, attribute values are from different sources are different. For example, we use centimeter or a meter for our measurements of some for as a scale of measurement for some products, but they may use like ounces or liters like that. So we have to be check all those data too, because different area, different location, different representation and different scales. So these kind of things we have to keep in mind while integrating our data from different sources. Next, data transformation. Data transformation means a function that maps the entire set of values of a given attribute to a new set of replacement values. We are not completely changing the concept of the data or value of the data. We are doing some kind of replacement or a transformation. That means that each old value going to be identified with the new values. For example, 2 cross 2 is considered to be 4, or it is going to be written as square root of 2 square. Both are same. So similarly, the values cannot not going to be changed, but the transformation, we are going to do some transformation and not changing the originality of the data. So there are few methods we are going to apply for data transformation. One is a smoothing technique, that is removing the noise from the data. And the next one is attribute or feature construction, that is new attributes are constructed from the given ones. And then aggregation, that is summarization or data cube construction. Normalization, we are going to scale to fall within a smaller specified range. There are various normalization techniques like min-max normalization, z-score normalization, normalization by decimal scaling. And the last concept is discretization. That is, discretization means we are converting the numerical values into some discrete values, with the support of histogram analysis and then binning concept, that is concept hierarchy climbing. So these were the few methods which are going to apply on a data set for the transformation of that old value with the new ones. And the last one is data reduction. The data reduction can be in terms of feature selection or feature extraction. That is, what I mean by feature selection. Selection means collecting a subset from the original set of values, whereas feature extracting, we are going to generate a new feature from that existing data set. Some of the examples like these kind of feature selection is applicable in model prediction like microarray data, text mining, weather forecasting, image processing, etc. Whereas in feature extraction applicable for ECG signals, wavelet domain and image data, etc. So both this feature selection and feature extraction concept will comes under the dimensionality reduction. It is one of the concept of the data reduction. Under the feature extraction, we are going to use an important topic called principal component analysis for the data reduction. It is a dimensionality reduction that identifies the important relationship in our data and transforms the existing data based on these relationship and then quantifies the importance of these relations so that we can get the most important relations and drop out the others. But to do this process for the dimensionality reduction and to identify that important relationship, we have to follow some few steps and to come for that principal vector or a principal component. The first step is to subtract the mean from the data and calculate the covariance matrix, calculate the eigenvectors and eigenvalues and select the principal components and reduce the data dimension. So these were the few steps we have to follow step by step or one by one to achieve the data. So then after that dimensionality reduction, we transform our data using the eigenvectors into principal components. We quantify the importance of these relationships using eigenvalues and keep the important principal components. That means the important data will be maintained as it is and the unwanted data will be reduced in terms of dimensionality reduction with the support of principal component analysis. So these were the four important pre-processing steps like data cleaning, data integration, data transformation and then data reduction, which supports highly for creating a model with a proper data set. Thank you for watching the video.